and then I mechanically tie it back, can I let sleeping dogs lie? Do I care about the support anymore? And what happened 75 years ago in the back there? Because I have all new Hilti bolts. Now I've basically duplicated the connection. This is how you eliminate the 3% that nobody knows about. Yes?
Don't use the same epoxy we used in the tunnels.
Yeah, no, this is special on those, you know. At Building 19, you can buy those by the thousands now. But yes, that's a, and just so you know, that's another process. You know, in Seattle, they have a hole inspector. You can't put an epoxy bolt into any hole until you have the hole inspector come out and verify that the hole is right, clean, then you can do the epoxy. So again, there's answers to all these, but what I'm trying to do is that in a fire escape, there's so much redundancy. There's a connection into the wall on a fire escape, usually every 4 feet. So, and the fire escapes are all tied together, so even if there's a failure of one of the supports, all the other supports are in one way acting in unison with it, okay? And that's one of the reasons why I sometimes say, don't put a single bolt next to a connection. I recommend an angle, a 4x4 angle, for example, underneath all the supports. And every 3 feet there's an epoxy on the angle, single piece, a 12-foot platform, for example. And then where they meet the support, there's a mechanical clipping that basically picks up the support. Have I just nullified 3% of your concern? Do I need to load test it anymore? If I verified there's no rust in any of your connections on 97% of your fire escape, because I refurbished it or I verified that there is no rust in there, and on anything that's an old bolt, I either backed it up or I swapped it out. And then on the 3 that I don't know, I didn't want to go inside that guy's house and tear up sheetrock and verify things in the wall. I just said, you know what, it's cheaper for me to just nullify some of these supports through duplication. You still want to order a load test? Or is that a certified repair? Because it's in your language. It says certify and or test. So that's all that we're doing here. We're just trying to get you guys to say the word load test. When's the last time somebody saw a load test? Or watched one in their career? I'm 50 years old. I got dragged into this by my dad, who's still in the business, when I was 10. I've only done one load test in my life, and that was in California. And that wasn't ordered by the official. The owner wanted a load test. But nobody does load tests, but every now and then it's forced, especially down in down in New Jersey. The first word on a violation is load test your fire escape, or give me an equivalent certification. So this is where one of the biggest issues that we have. Now, there's also situations here that pieces of the fire escape are missing. Rails are missing. This is in New York. New York is notorious for having platforms that are only 12 inches wide, 18 inches wide. But they're pre-existing conditions. What do? To have them build brand new fire escapes, you can't. This is another case. A fireman actually fell through 3 treads that gave way here, fell down, went back up, and got a woman because he was ventilating this thing here. But the thing that changed about this case, this fireman actually sued the owner because not only did he get hurt during work, but he thought it was negligence because the owner had not maintained his fire escape for over 25 years. And they won. They settled the case with him because, you know, he was, when he fell, he broke some vertebrae and he wasn't able to work the rest of his life. He was only 27 years old. But this was a case that changed and reverberated a little bit because he sued the owner for negligence, not for a work-related accident. So let's take a look at now how fire escapes are built, and let's. This is part of the case study that we did that was one of the reasons why the case was won, I believe, in New York, is because we showed through a metallurgist now, this is backed up by the metallurgist on how long it takes to build fire escapes. We're going to use a tread as an example. Do you know that between 1900s and 1930s, there was hundreds of fire escape companies out there that they built every fire escape in New York, Chicago, LA, and then in the 1930s, when they took away the right to build fire escapes, guess what happened to every one of these fire escape companies? They all just went dead overnight. There was no more fire escapes. They all shut down.
They went to China.
Yeah, that's what could have occurred. So right now, in 1930 till the present day, guess who's been building fire escapes? Because there's no Home Depot to buy treads, supports, and all the knowledge that was done away with in 1930 didn't survive. It's rare that you'll find the book, and you find the book, but usually in a yard sale, in a flea market somewhere, you'll find some document that mentions fire escape in my book for some reason. That's how we found. But let me tell you, every piece of fire escape built today comes from a 20-foot length of material. I need to do supports, 2x2 angles, 20 foot. Treads, grading, 20 foot. Everything is custom built to satisfy. We don't build enough new fire escapes today to have a company out there that just builds fire escape and they're doing well by building just fire escapes. So every iron worker in your area, every welding guy in your area will make a custom built fire escape, onesie twosies, every year or so. So what does that mean? When you get two pieces of steel, you put them together, and you bolted, welded, or riveted it, was any of that primed or painted prior to putting it together? Not then, not today. Once you put the bolt there and you put things together, guess what happens with today's moisture and the heat and humidity? Guess what happens in that connection that was never primed? It starts rusting. It's right there that unless you, when you build a rail or tread of support, if you don't encapsulate that with full primer, guess what's going to happen to that connection? It's going to start growing from the inside out. But as soon as you seal it with paint, guess what it needs in order to grow? It needs air and moisture. As soon as you seal it with paint, guess what you don't get? You don't get any air or moisture, so the thing stays there. So this is what happens when you have the first time, within the first 5 years of a connection being built, to support or tread, you get surface rust. All you have to do with surface rust today or 75 years ago is scrape it and paint it, and that connection will always stay sealed. Did people today or people 75 years ago scrape their fire escape or just keep painting over it? Keep painting over it. So you got the next level. The rust now has a way to get in there because every time you paint over rust, within a month or two, splits, water gets back in there and it keeps feeding water to the connection. And this is the most critical one because it's treads. Treads is where everybody gets hurt. As soon as it gets there, whether it's a 16th, an 1/8, a 1/4 inch, is that connection viable or not? Will the engineer sign off on a connection that has rust inside? He'll never sign unless he doesn't see it. But what's stopping you and the tenants from falling down? The only thing that's stopping, even though this thing's got a 1/4 inch of rust, the only thing that's stopping them from falling down is that bolt or that pin is actually blocking the angle from dropping. That's all. That's what's been saving you all those times you've gone up and there's rust in the connection and you never fell. Because the clip can't go any further because it's blocking its ability to fall. So all of a sudden now you go into the next step. As you give it time and you let the rust grow to 1/4 inch, 3/8, 1/2 inch, guess where that pin is now? It's away from the angle clip. And now you step on it, or the fireman steps on it, or the child steps on it, or never the landlord steps on it. It basically falls. So it takes about 50 to 75 years for fire escapes to stop falling apart. Guess where we're at? Was this a big issue 25 years ago? Nope. 50 years ago? Nope. Is it an issue today? Now that we have all these fire escapes with this much rust in it? The answer is yes. 2 years after our exam of the fireman case that we did in New York City, look how much rust was still in the fire escape. And as we were walking up, we had to stop the investigation because as we were walking up, treads were falling out underneath us. But guess which treads were perfectly repaired? The 3 that the fireman fell through. So this is not a Boston problem. This is a nationwide problem because there's no standard for inspecting, no standard for repairing. We put it all together, and by January 1st, we're going to be starting the Firescape Association, or it's either going to be called the Firescape Association or the National Firescape Association, so we can put these standards in there. And the people we're going to be looking for to join that, to make up the board, is going to be firemen, building inspectors, vendors, structural engineers, because a lot of these standards, they need a place to be put so that people can accept it. So we need to, we've basically started the Firescape Association with the very people that we teach a lot of the classes to. And that'll help. Let's talk about if you look at your, this is the drawing that, if you want to open up to that page now, and I'll keep moving quickly on this so that way we can finish on time. If you go to this page, all fire escapes in the United States. I apologize that we have to make these little thumbnails. We can blow these all up for you, but this is just so that we didn't have so much to print. But I'm going to talk to you about how fire escapes are built. Every fire escape in the United States is going to be covered right now and how they're built. If they go into masonry, every fire escape is going to be covered right now if it goes into wood. There's no other way to build these things. Okay? This is the only way that they're built. And the way they built them 100 years ago is the same way we build them today. Nothing's changed. So you got steel that goes into the wall. If it goes into a masonry wall, it's 8 to 12 inches deep only. That's it. It penetrates the veneer and then it goes into the masonry block wall, which is either more brick wall, 2 or 3 layers of brick wall, or it's masonry block. And they just dig a big hole, stick the thing in there, pack it with cement, done. That's how it is. these things spall and they crack. And a lot of times, the guys who fix these things, guess what they fix? They fix it right here, right on the veneer. You know, they drill a little bit, they break out some of that thing, and they pack it right at the veneer. What about behind it? You think they ever go deep behind it? Nope. Okay? So that's the important part, is that behind it is where the strength is, but the guys are all packing it at the nose. This support is missing here, the arm. And it's got two full staircases on a single one that's only buried 8 to 12 inches deep. You put enough firemen and people on that, think that's going to pop down and cause a catastrophe? The second type is the single arm plus a bracket. This is typical. And they all either have a single bolt there or a gusset. And the bottom also has, it's tied into the building. Man, so much water gets driven in there all the time. So this is a lot of source of water is just from these right here. So again, I have to, a lot of guys